let's get started. Hope you guys can see the screen now. Can we see the screen now?
Yes, we can.
All right. So now the first thing to do is to go to the Arduino folder. This is the folder. You extract the file and also extract the patch. So after you must have extracted the simulation software, you run as administrator. What I want you to do is that you run it as administrator. So you run as administrator. You say yes. So it's extracting. So I will not install because I have the software already installed. So once you get here, it will prompt the other instructions. You just follow the instruction and install the software. But I'm not going to install because I already have the simulation software, so no need. So I'll end the installation process here. Then after you must have installed the software, how is it? So after you must have installed the software, you look for the icon. So you have the icon here. This is Proteus 8 Professional. So let's open the software. Now, if you install a new Proteus, at this particular point, some of these things will be dead. They will be dead by default. So you have to copy the model and the bin folder to a particular folder before it will start working. So now you go back to your folder. Now you have bin and you have model here. So what you do is that you copy those two files. Copy those two files. You copy. Then you go to local drive C. You enter here. Then you look for Lab Center Electronics. Lab Center Electronics, that's the name. You will not see Proteus there. What you will see is Lab Center Electronics. So you open the folder. Then you paste. You have bin here, you have model here. So you right click and you paste. So you replace. It will ask you to replace the file in the destination. So you replace. Continue. So after you must have replaced the two files, then you go back to your software, go back to Proteus. So this place should be like this now, but initially when you install it, it will not be like this. Some of these icons will be dead, so they will not be clickable. So after that, you need to include the Arduino files, Arduino libraries inside your Proteus. So for you to be able to do that, you need the Proteus part where you can see the library. So you go to System for you to be able to see the.
Hello.
Yeah, I can hear you. I can hear you.
Hello, sir.
Yeah.
I'm saying that I have this challenge that I use a locally installed license key.
Yes. So
and use a LAN.
Okay, I can use what?
And use a license key installed on the server.
Yeah. The thing is, that's why I sent
These
you.
are
That's why I sent that particular link. So once you download that, I don't use any server or any locally installed anything. I have my parts already. So once I install, I copy the bin and the model folder to where they're supposed to be copied to. So once you do that, your Proteus will start working.
okay. So I should. Okay, I understand. Thank you very much.
All right. So, all right, I can hear you.
Depending on where you downloaded your Proteus from.
I can't hear you loudly. Your voice is kind of faint. Can you speak up, please? Can you speak up, please?
Can you hear me now?
Yeah, I can hear you now.
I said I have this issue. I didn't get your explanation on
All
the
right.
question you just asked.
All
I
right.
didn't get your explanation.
All right. So what you do is that I don't use internet to install mine. So once you download it, you are going to see the patch and the setup file. So once you have your part and your setup file, you do your installation normally. So after installing, you copy the two folders inside the part. The two folder, you have model and you have bin folder. So just copy those two folders, then go to, okay, let me show you. Hope you can see my screen, right?
Yes.
All right. So you go to your local drive C. You go to this particular folder, program files. Then you go to Lab Center Electronics, Proteus 8 Professional. Then you are going to see bin and models folder. So paste that particular files that you've copied from the patch. So look at our patch here. We have the one I sent. I included two files inside the patch folder. So this is what we have here. So we have the bin and the model. So you just copy these two folders. You go to your drive C, go to Lab Center Electronics, go to Proteus 8 Professional, then you paste the two files. So you are going to use it to replace these two folders. You have bin here and model. So replace it with the one that you copied. And once you've done that, you go back to your Proteus. Everything should be working.
Wow.
Are we okay?
Yes, I have a question.
All right, I can hear you. Go on.
I've copied the part, the bin and the models to that directory.
Yeah.
So, but after I copied it,
I can't hear you well, please. After you must have copied that, what happened?
After I copied it there and pasted it in that directory,
All right.
now I'm trying to open my Proteus back.
Yeah.
It's telling me that the possible point are Proteus.
I can't hear you. I can't hear you.
Okay, can you hear me now?
Yeah, I can hear you now.
Okay, what I'm saying now is that after I save that bin and the models to that directory,
All right.
the Proteus is not moving.
What you
That pds.exe has stopped working.
So what you do, just restart your laptop.
Okay. I will do that now.
So restart your laptop.
Hello,
Then,
sir.
yeah, I can hear you.
Hello, can you hear me?
Yeah, I can hear you.
I don't install my own. I think later I can install on the laptop.
All right. Yeah, once you install it, you can. If you're having difficulties, you can screenshot and post on the group chat. Then we can help you out.
I will do that later. Please just continue.
All right. So
Hello?
yeah, I can hear you.
I said I need to install mine on the laptop later after the lecture.
All right. Once you do that, then if you have any issue, you can post it on the group chat. Then we can help you out. So once you must have done that, then let's add our Proteus library. So what you do is that you go to System. You guys can see the screen, right?
Yes.
All right. You go to System. Go to System Settings. So library folder. This is the path. Please let's turn off our mic. Please let's turn off. If you want to talk, you can on your mic. But if you are not talking, just mute your mic. All right. So you copy this path. This is the library folder. This is the path for the library folder. So you right click and you copy. Then open your this thing. Then here you paste the path. This is the path. You paste the path and you click enter. So this is the library. This is the library. All the libraries that are inside your Proteus simulation software, we have them here. So now you go back to the folder. Then you go back to the folder. Then you go back to the folder. Okay, you have the folder here. So this is Arduino Library. You extract and copy these two files, Arduino tep.idx and Arduino tep.lib. So you copy the two files. Please, can we mute our mic, please? I don't want to mute everybody, so that if you want to ask questions, you can ask your question freely. Let's do it to mute our mic. Solomon, please mute your mic.
Go ahead.
Can you turn off your mic, please? Solomon.
Okay. It's okay.
Alright, so you copy the two files. Then you go to the library folder, library path. You paste. So I have it already. That's why it's asking me whether it should replace. So I will say yes. But I have the library before. I have it initially installed. So now once you must have done that, you close and go back to your Proteus simulation software. Now you can create a new project. So I'll click new. So I'm waiting for it to load. So you just move next, and you finish. I forgot to write the name of the project, but you can still do that here. So you go to file, you say save. So let me write the name of the project. File, save as. So I will name it power supply. Power supply. You save. So this is the environment. So if you want to look for the same library that you just included in Proteus, you just click this second icon here. So once you click here, you click P. Then you write Arduino. Just type in Arduino there. So you have a lot of Arduino here. This is Arduino Mega. You can see it here. You guys can see my screen, right? Can you guys see the screen?
Yes, you can see the screen.
All right. So this is Arduino Mega, but I want to add Uno. So I will write Arduino Uno here. Arduino Uno. So this is Arduino Uno. You double click and you say OK. So this is the Arduino Uno. So you can write your code and import the code there, but that will be for tomorrow. So I think we are done with the installation of Proteus and addition of Arduino Library and adding of Arduino Library. So if you have any question, you can ask before we move forward. Any question?
Okay, the lesson was very superb. May God bless you for this wonderful lesson.
All right.
But the issue is, I got the way you do your presentation here, but I have not put it to practice because I can't still open the Proteus.
Okay.
I can't still
You
open
know
the
what will happen?
Proteus.
You know what will happen? After this class, you can chat me privately. Let's figure everything out.
All right, thank you.
All right. So let's go to the last part of this class. So the last part is um, design, and please can we mute our mic, please? All right. So the last part is design and the simulation of 5-volt power supply. So we want to simulate 5-volt power supply using this Proteus that we just installed. Are we together?
Go ahead.
All right. You can see the screen, right?
Yes.
All right. What's on the screen so that we'll know that you guys are with me?
Simulation of 5-volt power supply.
All right. Exactly.
Difference between linear and something. Go ahead.
All right. So
Steps and stages involved.
all right. So now, please, once you are done talking, you can mute your mics so that we'll avoid the holdback. So now we want to design 5-volt power supply. The reason why we are designing this, even though you want to simulate Arduino, maybe you want to use Arduino board, you want to use controller, you want to use any IC to build your project, number one thing you should do is to design your power supply first. That's the first thing to do. You design your power supply. So now we want to design power supply, because without power supply, no device can work. Your phone has a power supply, which is the battery inside. Your audio amplifier, it has a power supply, which is inside. It doesn't work with AC, it works with DC. So you plug in your AC, it converts it, the power supply convert the AC to DC, and it will spread the signal to other parts of the circuit. So it's important that you design your power supply properly before you start designing other parts of your circuit. So now we are going to be designing a linear power supply. Now we have basically two types of power supply. We have linear and we have switch mode. Now linear is the simplest to design, it's easiest to design. You have your laptop charger, your phone charger, all those type of power supply, they are called switch mode power supply. But the kind of power supply you see inside your audio amplifier, they are called linear power supply. So today we are going to be designing a 5-volt linear power supply, and we have basically 4 stages. If you want to design a power supply, you have 4 stages. Number 1 is the voltage transformation. After you must have transformed the voltage, you rectify. After you must have rectified, you filter, then you regulate. You now have your output. So now the first step is to transform your voltage. We have about 220 here in Nigeria. Some persons like US use 120, 110 thereabout. But here in Nigeria we use 120. We make use of 220 volts. So now it's not convenient to work with 220. It's very dangerous. So what you do is that you transform the voltage from 220 or 240 to 12 using your step down transformer. So this is called voltage transformation, because you are transforming this voltage from one level to another. You are not converting anything, you are just transforming. It's still AC, but you want to bring it down from high volts to a lower voltage. So basically we have 2 types of transformer. We have step down. I've talked about a step up and step down, but in step down you have center tap and the normal transformer. The one by the right with blue, black and blue color, this particular one is called center tap, because you have 0 at the middle, you have 12 here, you have 12 here. but here is just 0 and 12. So this one is the normal transformer. So the application where you mostly use this type, the center tap, is when you are using an IC that involves positive and negative voltages. You know, we have ground and we have positive, we have your VCC, but in some circuit you have positive, you have negative, you still have 0. So in that case you use this right one, but today we are going to be using this, which is just 0, 12. So we are transforming from 220 to 12. If you are in USA, you can use transformer that transform from 110 to 12, so it will still work same. Now the second point is rectification. We've done our voltage transformation, we've transformed from 220 to 12. So now we want to rectify. Hope you guys can hear me. Are we together?
Yes, go ahead, please.
All right.
Yes,
All right. So now, after the voltage transformation, we'll rectify. Now, rectification is the process of converting from AC to DC. Because most of our circuits utilizes a DC. You don't power them with AC. Like your mobile phone is DC. That's why you charge. If you want to charge your phone, you use battery. Sorry, you use charger. So your charger converts that 220 to 5 volts. Then you can now plug it to your phone. If you send 220 directly to your phone, it will damage your phone. So for you to be able to do that, you need a bridge rectifier. You need a rectifier. So this bridge rectifier, you can get them. If you don't want to use the IC, you can form it using a diode. This is 4 diodes. So you have 4 diodes here connected together. But if you don't want to use the 4 diode, you can use this particular IC. It's called rectifier IC. So here you have 2 points. These 2 points are for the AC, and these 2 points are for the DC. The same way you have it here on the IC. You have the middle one. Please, let's mute our mic. The middle one is AC, these 2 middle one. Then these 2 outer parts, minus and plus, is the DC. So exactly what we have here, that's what we have here. Just that this one is a complete IC. It has these 4 diodes inside. But this particular one is made up of 4 diodes. This single diode. So now we have full wave and half wave rectification. I think because of time we'll not go in detail. Let's try and push it so that we start simulating our 5 volt power supply. So after rectification, you do filtration. I don't want to mute everybody, so that if you want to ask questions, you can ask freely. Please, Solomon, mute your mic, please. All right, thank you. Once you are done talking, you mute your mic immediately to avoid noise. All right. So for filtration and regulation, basically we use capacitor. You can use inductor too, but in most cases, in our simple linear power supply, we use capacitor. So this capacitor will filter some noise, because you've converted from AC to DC, but you still have some noise, some ripples. So to be able to filter those ripples and noise out, you use capacitor to do that. So after you must have filtered, you regulate. Now we want to regulate from 12 to 5 volts. So we use a voltage regulator to do that. Alright. So now this is the complete circuit diagram of what we want to do. Everything we just explained now is contained inside this diagram. So the first part is the transformer. So this is the AC and this is the transformer. So the transformer will step down the AC of 220 to 12. Then after that, this is the bridge rectifier. It will convert to DC, and this is our capacitor. It will filter, voltage regulator will regulate, and some other capacitor here. You have your output, which is 5 volts. So this is what we are going to be designing on the Proteus now. Are you guys with me? Are Are we still together?
We can hear you.
All right, all right.
Yes.
So we move forward to the Proteus simulation software to simulate the 5-volt power supply. Hope you can see the screen.
You can see the Arduino yellow.
All right. So now the first thing to do is you add your components. That's the first thing to do. You add your components. So now I'll be adding all the components that I need. Number one, I need transformer. So I'll add my transformer. So these are the transformer. So I'll select simple transformer. Then after transformer, I need bridge rectifier. So I will select bridge rectifier. After that, I need electrolytic capacitor. So I take the capacitor, the two capacitors. Then I need voltage regulator 7805. So this is the voltage regulator. I need resistor. Then finally, I need LED. So now we'll start designing our circuit. So the first thing is you add your source, which is the AC source. So I did not add the AC source. Let me go back and add it. It's called V sign. So you add V sign. So first thing, you add the V sign. That's the first thing to do. Then after that, you add your transformer. So the work of the transformer is to step down. You add the transformer. This is the transformer. So if you add, you connect. So we are connecting immediately. So we connect. Then after that, you add your bridge rectifier. So this is the bridge rectifier. Then after bridge rectifier, you have capacitor, right? So we have our capacitor here. The shaded part is the negative, so you make sure that it's down. So we need to move it forward a bit. All right. So after that, you have your voltage regulator, which is 7805. Then you still have a small capacitor for further filtration. So I'm rotating so that it will fit to what I want. Then you have a resistor. We want to connect indicator. We want to add indicator. Then LED. So you add your ground. For it to work on Proteus, in Proteus you need to add ground. So you add your ground, you go to here, terminals mode, you click, you choose your ground, you add your ground. Then having done that, you need to select your values, because you can't use this. You can use 10K anyway, but I think 10K is too much. We have calculations, we have a way of calculating that, but because of time, let's just move forward. So I select 10K, sorry, 1K. Then here you double click on this V sign, you tap, then go to amplitude, you change it to 220. Okay, then capacitor, you double click, we need 1000 UF. Yeah, this capacitor we need 10 UF, so you double click and you change to 10. So we are okay now. Hope you can see the screen. Can we see the screen?
Yes, you can.
All right.
Yes, you can.
Yes, yes.
So now we are done designing our circuit. We want to simulate to confirm that it's working. But before we do that, I want to add a voltmeter. So you go to I don't know the name of this particular icon, but you just move to here, you click here, then you choose the DC voltmeter, because the voltage you want to measure now is DC. So you select your voltmeter, you drop it here. So let's make a space here so that we can add our voltmeter. You move this guy, so you add the voltmeter here. I think the space is too small. This is the positive part and this is the negative part. So now you go down to the left down part. This is play, so you start the simulation. So you click there, it's on, but we're not having an output here. So let's check what the where the problem is coming from. All right. Okay, let me change frequency to 50. All right. So we have our 5 volts here. I hope you guys saw what just happened now. I did not include the frequency. I only added the amplitude. So you need to include the frequency and the amplitude for the V sign. So the amplitude is 220. If you are using 110, like your voltage is 110, you can add your 110 here. If your frequency is 60, you can add your 60 here. But basically here in Nigeria, our frequency is 50 and our voltage most times is rated 220. So once you must have done that, you start your simulation. So as you can see, we have plus 5.02 volts and our LED is on, showing that the circuit is working properly. So now this is the first step you take when you want to simulate, when you want to build any circuit. You first of all build the power supply. So I think we are going to be calling it a day here. So from tomorrow we'll start the simulation of the Arduino properly and we'll start writing our code. All right.
What if it's 12 volts to it?
I can't hear you. Can you speak up, please?
What if it's 12 volts?
All right. If you want to simulate 12 volts, now when I discuss the step that you need for you to design the 5 volt power supply, you understand that I talked about voltage regulator. Here we need 5 volts. That's why we are using this type of voltage regulator. This is 7805. So which means we can have output of 5 volts. So if you need 12 volts, you should use a regulator that will give you output of 12, which is 7812, or some other type of regulators. But mind you, your transformer should not be 12 volts, because in this case we are using 220 to 12 volts. But now, if you want to design output of 12, at least you are going to be needing 15 volts, like 220 to 15 volts. So this 15 volts, you now convert the 15 volts to DC, you can now use 7812 to have output of 12. But since we are using 7805, that's why we are having output of 5 volts. I don't know if I've answered your question.
Yes, sir. Yes, sir. It's answered.
All right. So any other question before we call it a day?
Yeah, I have a question.
All right.
Okay, my question is this. Okay, if, like the question the second man asked, that in case you want to need 12 volts, how about if the 7805 is removed from this circuit?
Yes. Now, if you
Then, and the transformer is 12 volts, so what is the effect?
yes, you are going to be having output of 12, but you know the problem? The problem is that
Okay.
our input voltage is not constant, it's fluctuating. The reason why we are putting voltage regulator, we want to have a fixed output, we want to have a fixed voltage, but the output of your transformer is fluctuating. So if you are not adding the voltage regulator, yes, you are going to be getting 12 volts, but if you connect load, it will be fluctuating. I don't know if you are clear. If you connect your load, it will be fluctuating. It can never be
Yes,
stable.
I actually get you, but hello.
I can hear you.
Hello.
I can hear you.
Okay, I got your point, but to my understanding, maybe we should simply put that if the voltage, the input source.
I can hear you. Go on.
Go ahead. From the load, you also increase.
I did not hear. I did not hear what you just said. The network. I think network was bad. Can you repeat yourself, please?
Okay, what I'm saying is this. I got your point.
Yeah.
But to simply put, in case there is an increase from the input, from the source,
Okay.
maybe from like 220 to like 240, 250,
All right.
automatically the voltage from the secondary transformer increase also from 12 volts, increase higher, and that will increase our error loss also. To damage the component we want to use it.
I am sorry. I can't hear you. Your line is breaking very badly. I can't hear you. So please, do you have any other question?
Hello.
Yeah, I can hear you. Yeah, I can hear you. You can go on.
Yeah. If I understand you, you said because we want to get 5 volts, that's why we use 7805. Am I right?
Yes, exactly.
Am I right?
Exactly. Yeah,
Okay.
you're right.
That if our aim is to generate 12 volts, that we use 7812. Am I right?
Yes, exactly.
Okay. That implies that instead of that 7805, we replace it with 7812. Am I right?
Yeah, you are going to. Yeah, but now, you are not just going to replace it with 7812, because now these voltage regulators, they have their specific input voltage. They have their specific input voltage and output voltage. If you want output of 12, you cannot give the regulator input of 12. It will not give you any output, or the output should be a bit lower. So whatever you are giving the regulator should be above the output rating. I don't know if you are getting the point. So if you need 12 volts, I think you should use 15 volt transformer. Don't use 12 volt transformer.
Okay.
Yes. So your input should be slightly above what you want to get at the output.
Okay.
Yeah.
Okay. So, excuse me.
Yeah.
So that means the more output you want, then we also have to increase the value of the transformer. Am I right?
Yes, exactly. If you want 24 volt output, your transformer should be above, the output of your transformer should be above 24. Because if you want 24, you cannot give input of 12 and you want 24. It's not a buck converter, it's not converting, it's not raising the voltage, it's simply regulating. So if you are regulating something, it means that input is more than what you are expecting. You want to regulate the flow of water. It means that the water is coming, like the speed of, or the pressure of water is too much at one end, so you want to regulate it, you want to reduce it. So what is coming in should be more than what should be at the output side.
Okay. Thank you very much.
All right.
For this is wonderful. God bless you, my brother.
All right. So we'll call it a day. We kick off tomorrow. Tomorrow is going to be
Thank you very much.
very great. All right.
Have a good night rest.
All right.
Thank you. Yes.